Hello friends, welcome to my YouTube channel Make Maharashtra. So we have seen the design procedure, how to solve the numerical. Now actually we are going to solve the numerical. So I'll read the numerical and follow the step which I told you in previous session. Just see, I'll read it. A pulley of 1000 mm diameter. So the diameter of pulley is 1000 mm is driven by an open belt drive from 25 kilowatt. So pulley is diameter of pulley capital D, bigger one, and their power they have given because it is output driven. Then they have mentioned 1440 rpm electric motor. So RPM of the motor 1440. The pulley on the motor shaft is 250 mm in a diameter. Correct? Motor shaft means on smaller pulley. So diameter of smaller pulley is small d, 250 mm. And the center distance between the two shaft is 2 meter. This distance, center distance 2 meter, that is we can say C, value of C. The allowable tensile strength of the belt sigma T 2 Newton per mm square, and the coefficient of friction between belt and pulley 0.28 mu. The density of the belt material 900 kg meter cube rho. The face width of the belt, that is B, 125. This is 125. Determine first thickness of belt, small t. Second, length of belt, capital L. Now we'll have to check for the length, either it is open or cross belt. So see, here mention open type. So I know open type equation. Then initial tension, third one. So go sequentially. So you must draw the diagram. Basically, you must know what is the driving pulley, which is the driven pulley, capital D, small d, center distance. You need to indicate in your diagram first. First step, while calculating the thickness, we know sigma t, the thickness in the equation of the design procedure which we have seen, sigma t is equal to total tension divided by B into T. So in that equation small t is there, therefore T is equal to total tension sigma t into B into T. Correct? So this will be the value. So one by one we need to calculate this. How? Check it. Now first of all, first step is velocity of belt pi d n by 60 into 10 raised to 3. So d is smaller d because it is motor situated, that is 250. We have taken 1440 rpm for that, and therefore our velocity is 18.85 meter per second. Then power to be transmitted, P is equal to T1 minus T2 into velocity. So power they have given 25 kilowatt, T1 minus T2 into velocity 18.85. Therefore ratio, this T1 minus T2, this equation we got 1326.26. This will be the T1 minus T2. Third will be the angle of contact. Now this is the open belt drive, therefore here is the minus sign. So alpha is equal to sine inverse of d minus d divided by 2c. So d is 1000, small d is 250, and center distance is 2 meter, that is 2000. Therefore alpha belt angle is in radian 0.1886 rad. Clear? So now the belt is open type, so therefore angle of contact theta is equal to pi minus 2 alpha. This we have seen in the derivation, pi minus 2 alpha. Alpha we have calculated, that just convert, write down here 2 into alpha, it is in radian. So we'll get the value of theta angle of contact 2.76 radian. Correct? Next part, the total tension that they have given in terms of the coefficient of friction. So I can write T1 by T2 is equal to e raised to mu theta. So I have written here mu theta. So mu is 0.28 and theta we have calculated 2.76. So therefore T1 by T2 ratio is 2.16585. Correct? Are you getting it, dear student? So we have calculated this T1 by T2 ratio, and we have calculated here the relation of T1 minus T2. So here if I can say T1 is equal to 1326 minus T2, if I put this value of T1 here, or T1 is equal to, sorry, like this way we need to calculate, just check it. If I take T1 is equal to 2.16 times T2, so I will have to put this value in T1 here. So by solving this, I'll get the value of T1 and T2. So first of all, TS, that is T2 will get TFS, nothing but T2 by putting the equation 1135.01 Newton, and T1 is equal to 2.16 times, therefore it will be 2461 Newton. So here we'll get the value of T1 and T2. Then we move toward the centrifugal tension. Now centrifugal tension we know as per the sequence, Tc is equal to mv square mass, and mass can be converted into density into volume. Therefore the equation is rho into b into t divided by 10 raised to 6 into velocity square. Now rho is 900 kg per meter cube. They have given width, that is face width b 125, you can see in the given data 125 here. So we just kept here 125 into thickness, we don't know right now, into 1 into velocity, that is 18.85, which was our first step. Therefore centrifugal tension is 39 point something in terms of T, thickness we don't know right now, therefore it is in thickness term. But we know the equation, total tension is equal to T1 plus Tc. So same equation they have written here, T1 2461 plus Tc, centrifugal tension in terms of T we have calculated. We know this equation, sigma T is equal to total tension divided by Bt. Total tension we know and B also known, and now we need to calculate thickness. Therefore by putting the value we will get the thickness 11.72, that is mm. So that would be the belt thickness for this much amount of power transmission. So first part is over as per their given data, thickness of belt. Then they are asking for length of belt drive, correct. Now length of belt drive, we know the equation, this is open type, so this is a minus sign here because of this for this term. So I can write L is equal to 2c plus pi into d plus d divided by 2 plus d minus d bracket square divided by 4c. So c is 2 meter, that is 2000. Capital D small d we know, and by putting this we'll get the length of open belt drive for this transmission of load, that is 6034 mm. Second part is over. Length of belt. Then third part is initial tension. We know the direct equation of initial tension, that is Ti is equal to T1 plus T2 plus 2 twice of Tc. So Tc is nothing but this much, 39 we have calculated, and T right now we know. So by putting the T value we'll get 469 Tc. So I put here 469. By putting this I'll get the initial tension 2267 Newton, correct. Now here they have taken 11.72 and nearby the value 11.75. No need to take, you can make the calculation by using 11.72. Clear? By this way we can calculate the initial tension which was asked by numerical, that is initial tension. Okay, I think you understood the procedure. We have used same procedure which we have seen in stepwise procedure in last session. So I'll repeat the things how we have solved. So we need to calculate thickness, length and initial tension. Length is direct formula, initial tension is direct formula, but to calculate the thickness we need to draw the structure first, indicate capital D small d center distance. Then we start with the first step, that is velocity of the belt, then power to be transmitted, then angle of contact that through which we can calculate the theta for open belt drive. Because of open here minus sign is there. Then limiting tension T1 by T2 e raised to mu theta. Why I have used this equation? Because mu and theta, mu is given. So therefore this equation T1 value will get, and here T1 minus T2 one equation will get. So by comparing these two equation I will get T2 first. So the T2 will be 1135 and T1 will be 2467. So this will be the value of T1 and T2. Once we got the value of T1 and T2, will move toward the centrifugal tension centrifugal tension Tc. So Tc is nothing but density into volume. This is the important while writing the centrifugal tension in mass is nothing but density into volume, that is rho b into T divided by 10 raised to 6 into velocity square. So by putting this value, centrifugal tension will get in terms of the thickness. So we know the total tension is equal to T1 plus Tc. By putting this we'll get in terms of again thickness. So we know the stress is equal to total tension divided by B into T. So total stress is given total thickness we have calculated, B is known, and thickness, therefore thickness is 11.72. After that, length equation directly I have used for open belt drive, therefore this will be the negative sign. Then initial tension direct formula we know, the Ti is equal to T1 plus T2 plus 2 Tc, and Tc we can calculate because earlier we don't know the thickness, but right now we have calculated here. So by putting this, I'll get the 469, and by putting this value in this equation, I'll get the initial tension is 2267 Newton. Clear? I hope you understood. Do practice from your side. Thank you.